welcome to this video tutorial on Earth geometry. In today's video, we're going to be focusing on how to calculate the angular distance between two locations that lie on the same line of longitude. Before we go ahead into our calculations though, we're going to have a quick review as to what a line of longitude is. Now, a line of longitude is in our category of great circles when looking at our Earth geometry. This is because it runs from pole to pole, and if you were to slice it out, it has the full diameter of the Earth. So these lines of longitude, the location is based off the east and west measurements. So depending on how far east or how far west it sits of the prime meridian. We have an example of a line of longitude on my little Earth drawing here. And another way to remember which way the lines of longitude lies is based off what shape your mouth makes when you say longitude versus latitude. You'll notice when you say longitude, your mouth and your jaw will naturally create a more longer and up and down movement. Versus when we say latitude, our mouth wants to go out lengthwise. So just a little tip there, if you want to remember between longitude and latitude, think of what shape your mouth says when you pronounce it. Going back to our angular distance, we need to be able to take any two locations along this line of longitude and calculate the angular distance between them. So in order to calculate these angular distances, we are going to use our north and south coordinates to help us. So if we were to, as an example, have a location at 20 degrees north and another location at 60 degrees north, we are interested, pretending we're slicing from the middle, in this angle here. Because they are on the same side of the equator, we are going to subtract 20 from 60, so we can see this has an angular distance of 40. We can do a similar thing if we have two south measurements. So let's say we had 40 degrees south and 70 degrees south. This angular distance here can also be found by subtracting. So we could say same, subtract when we are considering these angular distances. Sometimes our two locations will be on opposite sides of the equator. So we might have a location sitting up here at 45 degrees north and a location sitting down here at 15 degrees south. In order to find this angular distance, we add them. Now, we don't have as nice a way to remember adding in comparison to same, subtract, but essentially if they are different, we add them. So we are going to use this concept here to help us calculate the angular distance between three different locations. So we now have our three pairs of locations up on the board, and we are going to use our knowledge from here of angular distance to help us find each of the angular distances between these pairs of locations. Now, the first thing we want to establish is whereabouts these locations lie in relation to each other. So the first thing we want to look at is if there is a common coordinate in between the two locations. So we can see that location 1 here is 14 degrees south and 151 degrees east. Location 2 is 20 degrees north and 151 degrees east. We can see that 151 degrees east is common across both locations. So we can say that these two locations lie on the same line of latitude. So we can now use these principles to help us solve for our angular distance. Now we can see we have 14 degrees south and 20 degrees north. These two locations lie on different sides of the equator. So that means when calculating our angular distance, we will need to add these two values. So the angular distance for our first set of locations is going to be 34 degrees. We're going to repeat this process for B, our second set of locations, whereby again we're going to start off by seeing if there is a common value across these two locations. I can see that both of these locations share the coordinate of 5 degrees west. This is also telling us that they lie on the same line of longitude. Having a look at our north-south values, I can see that both of these values are south of the equator, so they're on the same side of the equator. We know that same subtract, so all we need to do is identify the larger value of the two, which is 22, and subtract 10 from it. So for these two locations, we have an angular distance of 12 degrees. Now our third location is presented a little bit differently to us, whereby it's not just in whole degrees. We've been given degrees and minutes within our coordinates. Now we already know that there are 60 minutes within a degree. So if we are looking at this 57 minutes here, that's the same as expressing it as 57 over 60 of a degree. Our starting process, however, regardless of how we've been given the coordinates, is going to be the same as our previous two examples, whereby we can see that we have 47 degrees and 25 minutes east that are common across both locations. Again, confirming that we're working on that same line of longitude. So we are looking at these starting values for each of the coordinates to see if we're adding or subtracting. We can see that both of these values are north, so we're going to have same subtract. We're going to take the larger value of the two, which is 27 degrees and 35 minutes, and subtract it from the smaller value of 21 degrees and 57 minutes. Now, depending on the calculator that you're working with to complete this calculation, there is usually a degree and minute button on there. So you can press this button, get these values, and it will give you an exact solution, which in this case is going to be 5 degrees and 38 minutes. However, if you do not have this option on your calculator, you can represent these values as a fraction if that helps you. So our first coordinate, we can technically represent that as 27 and 35 on 60, and then we can subtract that by 21 and 57 on 60. Okay, so if that gives us a decimal solution, we will have an approximation of 5.63 degrees. You should notice that if you type into your calculator 38 divided by 60, you will get the value of 0.63. So both of these final angular distances are equivalent values, and they both represent the same angular distance between these two locations. So that's a quick look as to how we can use our knowledge of locations on the Earth to help us calculate unknown angular distances between pairs of locations. Happy solving with your Earth geometry problems. I have no doubt that you are a pro now at calculating unknown angular distances along the same lines of longitude. Let me know in the comments below if there's any other Earth geometry concepts that you want to see covered in these videos.